Welcome, I am Dominic and this is Software Without Code. Let's predict which NHL players will be Hart Trophy winners without prior technical or coding knowledge using AI. I might use the terms machine learning and AI interchangeably, as in the context of this video they are the same. You can repeat this process for any other fantasy sports predictions you might want to make, assuming you have a data set. Data is the backbone of AI. Let's use Excel to visualize this. In this video, we will only be talking about data which can be modeled by rows in Excel, where each row is independent of every other row. Take this dataset here, for example. It is a dataset of hockey players. The dataset was obtained on the website Kaggle. The link will be in the description. I did not curate this dataset. These rows can be shuffled and they will still be able to be analyzed. An example of data which might fit in Excel rows but where the rows are dependent on one another is time series data such as stock prices over a period of time. Typically, a stock price is only valuable within context of the previous or next price. Each data point has a dependency on time or when it occurred. That produces a natural order to the dataset. Of course, in future videos we'll be analyzing this type of data. And you can imagine the clickbait title, Predict Stock Prices with Machine Learning Without Code. But notice in the hockey player data set here that there's a concept of year, but it is not time series data as the rows are not dependent on time. Furthermore, images, audio, text also won't work with the method in this video, so keep that in mind. It is also important to note in this data set that player name, position, and team look like text values, but they're actually mapped to numbers and are not considered text. This is generally the case when text is used to represent categories or things, because equivalently numbers could be used to represent the categories. But back to the problem at hand, the only other question to discuss about our data is what our objective is with it. In this particular example, with our hockey player data, as I mentioned, we are trying to predict whether a player will be a Hart Trophy winner or not. In other words, there are two possible outcomes, yes or no. This type of machine learning or AI problem is called classification. Each outcome is called a class or label. There can be more than two outcomes, but for our example, we only need two, winner, not winner. Though we won't cover it in this example, an alternative to classification is predicting a value that has a range. For example, imagine predicting outside temperature. It can take on any number of values to any decimal precision. These types of problems are called regression and are treated with a similar process to classification but are not the same. We will only deal with our classification problem today, which is whether a hockey player will be a Hart Trophy winner or not, represented in the column on the far right by either 1 representing winner or 0 representing not winner. We will be using a drag and drop software called Orange. This software is really powerful, but we're only going to concern ourselves with a small subset of features. The link to the download is in the description of the video, but you'll also see the URL in my browser here at the top. And feel free to pause the video to navigate to the site if you need to, if you're following along. Now to download and install, we just want to go to this URL, click the download tab, and then choose the appropriate version for our operating system. They do have a version for Windows, Mac, and Linux, so you should be covered. Alright, now that we have Orange downloaded and installed, let's just get started. This will be the screen when you first open it up. Let's create a new workflow or project. And now that we have the new project, this will look complicated on the left side with data, visualize, model, evaluate, and unsupervised tabs, but don't worry, we're only going to be using 2, maybe 3 of these in this video. Well, we'll be using 3 for sure. So let's start by dragging out, opening the data tab and dragging out the file block. Now, the file block is how you import your data. You'll note here, I've imported it previously, so it's already loaded here, but just for your reference, when you're first importing the data, you'll want to click this File Dialog Browse button, the file with the 3 dots, and find your spreadsheet. In my case, it's called NHL.csv. It's the one I showed earlier in the video, and then I'll hit Open. Doing so will load the columns here, and you will want to take a look at this before you just hit Apply. So, for example, I've chosen to ignore the rank column. I've also chosen to ignore I'm going to choose to ignore the season column. I want to be able to make my predictions independent of the year or season. And finally, you'll want to pick which column is your target. And I know I kind of skipped over this word, but I'm going to address it now, is the word feature. Feature just means the input to our AI system. So anything that is a feature is fed as an input to our AI system. Target is the output. So we're trying to predict the Hart trophy categorical variable, in other words, whether they are a winner or will be a winner or not. And so I double click this and just, it's already target, but you'll want to make sure that for your data set you pick what the target is. And then let's hit apply. Great. So once I hit apply, I can close that and then drag over this data table widget and connect the two by left clicking on the dashed line and dragging it over and then letting go on the data table. Double click the data table and you'll see your data. Now we should do a sanity check just to make sure that the rank column does not appear and the season column does not appear, as I chose to ignore those. Great. That's exactly what I expected. You can look through the data and, you know, browse it through this program, but I'm just going to close this for now because we took a look at it earlier. So let's get started. Our first step before we make our predictions on who the Hart Trophy winners are going to be is going to be to build multiple AI models and pick the best one, because we want to make our prediction using the best AI system possible, and we don't really care which one that is. Like I said, we'll just ignore the details of the AI system and just choose the best one. So I clicked on the model tab here and I'm going to drag out a bunch of most of these are AI models or AI algorithms that can be used to make predictions for classification. I'm going to drag out some of them. Not all of them are for classification. Some of them are for the thing I mentioned earlier called regression, for example, logistic regression. Linear regression. Logistic regression actually is for classification, and so let's drag that one out. So we're going to use logistic regression, SVM. SVM stands for support vector machine. We're going to use neural networks, Ada Boost, naive Bayes, and KNN. There are others we can use, but this is a good starting point. Hopefully we'll find one good one amongst these 6. So now that we've dragged out our models, let's click on the Evaluate tab. So we're going to be using 2 of these blocks. We're going to be using the test and score, and then eventually the predictions. And actually, you know what, we'll use the confusion matrix to show our results for the testing and scoring. So testing and scoring is used to select the best algorithm, which I mentioned we were doing. We will then, after we pick the best one, feed it to our predictions block, which will make predictions for who will be the Hart Trophy winner. So let's drag out test and score. And so for this one, we want to feed each and every AI system to it. They will be trained, or they will learn independent of each other, and then we can compare the results. So I'm just connecting each one to the test and score block. I'm now going to also drag out confusion matrix, not to be confusing, har har har. The confusion matrix actually will help us understand the results. It's the only kind of visualization that we'll be using in this video. There are more sophisticated visualizations, but I'm trying to keep this as simple as possible. Okay, great. So now we've connected everything. What do? Well, we're missing the final connection, which is we need to actually bring the data and connect it to the test and score. Now, when you're doing this on your own, you may want to pause the video, take a screenshot, whatever you need to do, because this same setup will work for any classification problem. This file can be, any data set for predicting outcomes, and you can use these same 6 algorithms. Some will, like I said, they'll vary. Performance will vary. You will see some perform better and others perform worse. But we will, I'll show you how to kind of interpret the results using this confusion matrix block. We're just waiting for this to run. You'll see the percentage climbing up. It definitely takes a couple seconds. I have a pretty good computer, and it's still going to probably take almost a minute to get all this testing and scoring done. But it's just about done now. So, yep. Okay, so it's done. So we'll just view the confusion matrix. I'm going to double click on the confusion matrix. Now, on the left here, you see all the different AI systems that we trained or that learned how to make predictions. There are all 6, and we're going to cycle through each one to try to understand the results based on this matrix on the right. And please don't be confused by this matrix. I'm going to explain how it works. So at the top, this top 0 and 1 right under the predicted is what the system predicted. So in other words, 0 is they will not win the Hart Trophy. One is it predicted that they will win the Hart Trophy. On the left, we have 0 and 1 also, and this is what the actual true result is. So they did not win the Hart Trophy, and then 1 is that they did win the Hart Trophy. So interpreting this diagonal, so the 13,040 and the 9 are what the AI system correctly guessed. So in other words, it predicted 0, or predicted that it didn't win, and the actual was that it didn't win, and it got that for about 13,040 of them. Similarly, on this diagonal, it predicted that the player would win, and the actual result was that they did, and it got 9 of them correct. So interpreting the incorrect results are on the off diagonal here. And so this just means that it predicted that the player would win, but they didn't actually win. And then similarly here, predicting that the player would not win, but in fact they actually did. And so these results, it got some incorrect. It got about 7 of them wrong out of 13. And, at first glance you might assume that that's not very good, but we have to actually compare it to the other systems to be sure. And we need to, compare the relative scores or accuracy. And the thing to understand here is that you will never, ever get a system that is 100% accurate. Machine learning or AI will always make mistakes at some level, and it's just important to measure and understand what those mistakes are. So KNN stands for K nearest neighbor. If I didn't mention that earlier, is what we just looked at. Let's look at naive Bayes. So naive Bayes is interesting, and you might be tempted to look at this and say, oh look, it predicted all 13 that would win, and so in other words, it got all 13 correct of the Hart Trophy winners. But then you look at this cell, and this is kind of alarming. It predicted that 2,331 of them would win, when in fact they didn't. So it's actually the worst. This is actually a really bad result. Another way to think about this is, imagine you're doing diagnoses for a disease, and you set up an AI system to diagnose whether 100,000 of your patients have some disease. You know that it, on average, it only affects about 2 in 100,000 people, but your AI system comes back and says, well, 1,000 people have this disease. You don't want to tell 1,000 people that they have this disease. That's just bad. When in fact you know that maybe 2 of them, or plus or minus a few, have it out of the population. Similarly here, this is just, basically saying you're a winner, 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 kind of a catch-all to attempt to get it. And it only, it guessed all 13 right, but it got like 2,331 of them wrong. So I would say that this is performed much worse than the KNN or K nearest neighbor algorithm. But let's continue through, and I'm going to go a bit faster through them now. ADA boost. So this seems like an okay result. It guessed as many would win incorrectly as would not win incorrectly, and it got about 8 of them right. Comparing it to KNN, it's kind of ambiguous as to whether you think whether it's a better result or not. It just depends on what you care for. So, for example, if you, I would say KNN seems a bit better actually, but ADA boost might work for you in your specific circumstance. It just depends, but there's similar results. So let's keep going. I'm going to look at logistic regression. Oh, logistic regression looks pretty good. It's important to know that it predicted that 7 players would win, and that didn't. So if your system, and the term for this is false positive, when it predicts true when the actual result is false. So in other words, it predicts 7 winners that are not winners. And if your system can't handle false positives, this might not work for you, but I think for our case it's not bad. It definitely overguessed on winners, but it got more of them correct as well, and it was wrong on the actual winners only 3 times, which again, no system's perfect. This one doesn't seem too bad. Now let's continue to SVM. So this one doesn't seem to look like it did very well, because the actual results, it predicted 0 when in fact 9 of them won, and it only got 4 of them 4 of them correctly guessed on who the Hart Trophy winners are. And finally, let's look at neural network. Neural network looks very similar to Ada Boost, but slightly better. And you know, it looks very close to KNN, but I would argue KNN is probably better than KNN probably outperforms Ada Boost in neural network. So if I had to choose which one I wanted to use, I'd be between logistic regression and KNN. And actually, just looking at this, I'm going to go with KNN. I think it performed well enough. So just to make it clear, there is another step that we can do that would typically be done, which is called pre-processing. So what pre-processing does is it shapes your data, either, you know, centering it around the average or scaling it down or up to make sure that all your inputs are the same. So if we take a look at this data table, just to explain that a bit better, you can see here that, like, for goals and assists, these are and actually points and goals, these are very different scales. So typically, not for all machine learning algorithms, but definitely for some or many of them, you want to normalize these values to be between like 0 and 1 or -1 and 1. And this orange can do that for us, but it's a little beyond the scope of this video, so we'll probably do it next time. So now that we've chosen KNN, we're going to actually make our predictions with it. So I set aside some rows from the data set for predictions. There are players from 2012, which include one Hart Trophy winner, which was Malkin. I intentionally removed those from the data set, and the reason for that is, you can imagine, if you give, just as an analogy, if you give a student a practice test, you know, a week before an exam, and they use the practice test to study for the actual test, if you use the same questions from the practice test on the actual test, it's hard to measure if they actually learned anything, because for all we know, the student could have just memorized the answers. Same thing for machine learning systems. I'm going to drag on the Evaluate tab the predictions, and we'll make predictions on data that was not included in this testing and scoring. So we have our predictions. We're going to drag out another KNN. Think of this as a completely separate system. And in fact, you wouldn't need to do this first step of picking the best one if you already knew which one you wanted to use. And let's bring out a file object, and it feeds a bit differently, but that's okay. So for file, I double click on it. We're not going to use NHL.csv. We're going to use predictions.xlsx, which is the Excel sheet I set up. I chose to skip the Hart categorical variable because we're trying to predict that, so it doesn't matter that we already know it. We're going to just ignore it. Similarly, I chose to skip season before, so I'm skipping it, and rank is already skipped. It's important to know that these column headers in the spreadsheet, which are represented by this name column, have to be the exact same in the predictions file as in the original data file. Otherwise, this won't work. So I hit apply. I'm going to close this, and then I'm going to feed the file to the KNN, and then the KNN I'm going to feed to predictions. And sorry, I'm going to actually, it's good to know because, you know, you have to know how to remove these. I'm going to actually remove this connection, this data connection. I'm going to right click on it, click remove. I'm going to move it here. I'm actually going to feed the original file to the KNN. So you can think of the original file as feeding the KNN it trains on this original file. It uses the data to train itself and learn. I know we already did that over here for this KNN, but we're going to use a different one for our predictions. So we train it first, and then we connect the file to a predictions tab. We double click on the predictions, and we drag them over here. So now we can take a look at what the predicted results were. So I just dragged that over. I dragged this over so we could see. So for Malkin, it predicted 1, which means it predicted Hart Trophy winner. These are the probabilities, like 60% chance of Malkin winning, 40% chance of him not winning, but ultimately we round that up to 1, or at least the KNN does that automatically. And for the rest of these players, They predicted 0, which was correct. So overall, it did get the predictions right for this particular small subset of players from, I think, 2012. You should know that, and I'm just, to be perfectly blunt, it will get results wrong, and we know that based on the confusion matrix we saw earlier. But that's okay. That's the case for all AI systems. So if you get your prediction data out and take a look at it here and see that it's way off, don't worry. You can always try a different system, or add more data points to train it on. Thanks for watching. Don't forget to hit the subscribe, the like, and let me know what you want to see next. I'm going to do a lot more machine learning videos, not necessarily all of them with Orange. I've also been using a software called Weka, and we'll be exploring machine learning topics a lot more. Get ready for the clickbait title of predicting stock prices with machine learning without code. Thanks for watching.